I represent Dr. Jim Frank from the Combating Terrorism Technical Support Office. We have a clicker. Aha. So the mission at CTTSO, we essentially are a rapid prototyping shop. We work for the Assistant Secretary of Defense for Special Operations and Low Intensity Conflict, and we're divided into 10 subgroups who each have their own focus areas. But our primary job is to deliver a prototyping capability to primarily Department of Defense end users, interagency partners, some of our friends overseas. We have bilateral agreements with the UK, Canada, Australia, Singapore, and Israel to do joint projects. What we're trying to do is reach all those little government offices that aren't big enough to have their own science and technology officers, their own R&D departments, and give them ability to bring something into production that would solve an immediate problem that they have that can't make it through that vast government bureaucracy up to the top to decision makers that are spending money. So the cool thing about us is that we serve a lot of little customers, but we have a seat at almost any table that we want to get to. It's not a big seat, but it's a seat. All right, so the Advanced Analytics Capabilities subgroup is Dr. Frank's subgroup, and that's the subgroup that I particularly work for, as well as managing our institutional relationship with Singapore. But essentially, we work for the Department of Defense first, but also the rest of the government. So you can produce a requirement out of Homeland Security or Customs Border Patrol. We even actually have projects with the NYPD or with the Sacramento Sheriff's Department. As long as you can make a reasonable argument that you are combating terrorism in some form, we're willing to work with you, provided the budget is accommodating and you're producing a good requirement. So these are our focus areas, and this is kind of where we start to get closer to what Vane is and why it is that we're doing this particular project. So anticipatory analytics and foresight is what Vane falls into, but we also do big data algorithms and decisions, decision tools, and then what we're calling battlefield analytics at the edge is really the ability to push computing power out a little bit further to the warfighter so that they can run applications in the combat zone that are going to increase their situational awareness. So I guess let me give you the why piece of this. So the open source anecdotal example is Crimea, the Crimean Peninsula in 2014. The Russians around January and early February, the Euromaidan protests kind of crescendoed, and at a certain point, Viktor Yanukovych, who was at least sponsored in some degree to his candidacy to the presidency in Ukraine by Moscow, he lost his nerve and he decided to flee the country and head back to Russia. It was at that moment, the 21st of February, that President Vladimir Putin held an all-night meeting, and they planned for the annexation of the Crimean Peninsula as a strategic necessity for maintaining Russia's access to the Black Sea. A lot of that campaign planning was built around information operations. And what we decided after that particular chaotic year was that the US government needed a way to interpret things out of open source information that are not being directly reported. And that becomes very handy when you talk about things like black propaganda and information operations, as well as little green men seizing intersections and strategic infrastructure around places in Eastern Europe. And Russia's not really the only example. ISIS is very, very dependent on being able to do information campaigns. They're relevant in the South China Sea. They're relevant in Syria. So with that, I'd like to introduce you to Brian Frutchey, who's going to talk about our project, Virtual Anticipation Network.
That's right, the Virtual Anticipation Network. So as Curtis was describing, there's this new phenomenon we call hybrid warfare. And so this slide gives you a bit of a visual representation of what that's doing to our defense readiness posture. We used to have to worry about the upper left-hand corner on the screen there, conventional warfare, right? We had to count as an intelligence professional. We had to know where the tanks were, where the soldiers were, where the planes were. It was a scoped problem that we knew how to do very well. With the emergence of this hybrid warfare, which is really non-kinetic conflict, competing for the hearts and minds, competing for the economies, competing for the information domain within regions of interest, that broadens the aperture of what our intelligence professionals have to deal with. So the virtual anticipation network was to help solve this problem, right? What is it? Let's actually be a bit more specific about the things that hybrid warfare makes more difficult. One, we've got to look at more sensor data. We can't just count planes and tanks anymore. We got to look at the information domain, the cyber domain, the economies, the environment, all those different domains, something we call the PMESI domains, are now important to the military. And we have to be able to do that with the same number of analysts. We have to be able to observe that environment with the same number of people. So we got to figure out a better way to scale. The threats that we're dealing with are more subtle, right? It's easy to count a tank. It's much harder to say, is that fake news, right? The threats develop more quickly, right? Modern technology, things are networked. How often do we wake up and some tweet has now dethroned a politician? Threats can occur very quickly. The Arab Spring happens very fast. Protests in Hong Kong pick up overnight, right? We've got to be more agile to respond to the threats. And we have to be able to present information to decision makers, right? Our government officials, the decision makers, are not data scientists. They are not going to become data scientists. We have to be able to express information to them, insights in a way they can digest. We don't have to spend 4 hours trying to get their attention to listen as we speak to what it is we've figured out. And so again, going to that idea of agility, the current methods we have are very human, building out agent-based simulation events and doing staff element research. It just takes too much time. We're not being nimble enough. And of course, we want to make sure we're trying to remove as much human bias from our intelligence process as possible. So with all those things in mind, we set out to help build what we call VANE. VANE is an idea to produce a data-driven forecasting and decision support platform to meet a requirement really from the Army Intelligence Directorate, which they call winds of war, right? Winds of war is what is blowing us towards conflict so that we can mitigate those threats before it results in conflict. You might have heard the term left of launch or left of bang. It was made, well, anyway. So the VANE was to help us produce that anticipatory intelligence that lets us understand how systems behave so that our decision makers can pull the right levers to help those systems move in the direction we want them to move. We're not here trying to predict the launch event that's going to happen. We're here to say, here are the drivers of things that make launches more likely. And if we want less launches, we should do these things, right? And give them some quantitative insights to that. So it's a data-driven platform answering questions like, what does the future hold for X? X being some sensor that we have on the ground. What it might, again, this is a low-side discussion, so we're talking about public available data, right? We're talking about demographic data, econometric data. We've got news, we've got social media, we've got all the things that you can collect off the web, right? We plow them into this system. And so when we say X, that might be the number of protests in a certain part of the world, right? Because we can measure and count the number of protests. How does the future change if X occurs? If I deploy more troops to Poland, what does that do to Russian cyber activity in Estonia? That's the decision support part. Being able to determine if this is the end state where I want to be, how likely am I to get there? And what are the things that are driving me there? What relationships drive me in that direction? Is there anything I should be paying attention to, right? This is an indicators and warning system, we call it. So we just want analysts to be able to sit there and they wake up in the morning and boop, there's something on their desk. You should probably look at this, right? And then, of course, being able to look is data-driven. So let's look back in the past and say, what has been happening in the past so we can assess those things since we have the data. So what is the data? On this, so keep in mind that we operate in multiple different domains, and some of our information isn't available in all those domains. So in the low-side domain, this is the data that we're currently pulling into VANE. A lot of it you're probably very familiar with, but you'll notice that we are trying to build a model that spans lots of different topic areas. So it's not just one area. We're spanning everything from economies to weather to cyber, and a lot of these sources are not terribly pristine, right? I think a lot of folks might know GDELT, right? GDELT, they have some NLP that's processed. There's 17,000 different news sources in 70 different languages. A lot of automated processing to convert it all to English to do some entity extraction. So every time there's an Air Jordan sneaker getting sold, there's an event that happens in Jordan, the country, right? So there are some known errors in these sources. Plus, GDELT's not doing anything to figure out where the fake news is and where the bad reports are. They're just collecting everything, right? So that's one of our sources. We have many, many other sources. And we're pulling from these over 660 different time series, right? And we're pulling that back from 1998 till now. So it's a good chunk of data. And that data has those problems. We have the issue of error. There's outliers. There's collection gaps, right? So if you guys have worked with, like, WDI is one. If there's a conflict, like there is in Syria, they're not going to report some of their statistics, like electricity usage. You'll have gaps during conflict years, right? So we have problems with the data. And often as a data scientist, right, you've got to impute those missing values. You're going to throw away those rows. But those kinds of things may very well introduce error into your modeling. So we're actually latching on to a family of algorithms called tensor completion. We're doing this we kind of started working with the Dr. Devaraj Shah at the University at MIT. So he kind of claimed to fame is 8 years ago, he and his team won the Netflix challenge with an algorithm called matrix factorization. If you've heard of that, it's now the de facto recommender method for if you want to go in retail and recommend users like you also like stuff like this. Matrix factorization is a great way to do that. Knime actually has a node that brings in the Spark library right into it to use that. We've extended that two-dimensional or low-rank tensor form. So matrix factorization is a two-degree form of tensor completion. We've extended that into multiple domains because, again, the real world isn't just users and ratings, right? 2 dimensions. It's countries and sensors and different time dimensions. And there's a lot more that goes into our tensor. But the power of tensor completion is it finds relationships not just between 2 entities, but between the features that I'm using to model the relationship between the 2 entities. So think of it as a model where everything predicts everything, right? And allows me to, this is an example that we pulled from an open source library, where you can feed in, the left-hand column is garbage data. Feed in some images where you have pixel error, where you have obfuscation, entire chunks of the image have been intentionally removed. And the tensor completion algorithm will learn what it can about how pixels and edges and colors relate within the image and give you the middle column, a reconstructed view of what it thinks the data should look like. And depending on the tensor completion algorithms that you apply, this can be either linear, nonlinear. There's a lot of research going into how you can apply the different specific completion methods. The other benefit is we actually get a matrix that tells us where the suspected error is inside the data. And so if we have the ability, as the government does, to task collection, we can say, hey, our model says if you go get me this data, we can be better about our predictions, right? So a lot of value to the tensor completion methods, and really to bring this to bear, we're using Knime, right? So Knime is great for many reasons. I think everyone here, I don't have to preach to the choir, but for the government, I think some of these lessons are doubly important. A low-code environment, there are very few developers, or even less and less technical specialists working in the government. So giving them a platform that lowers the barrier to entry so that they can engage productively with the actual developers is important. I mean, handing a government program office thousands of lines of code and saying, hey, why don't you audit what we did? That is really hard for the government to deal with. So Knime gives them that ability to communicate effectively and even contribute to the development process. It's incredibly extensible. I got to tell you, nothing that we do ever seems to be quite what's out of the box with any of the vendors we work with. And so the fact that we can write, we've written over 15 different custom nodes. We've got a lot of great things that help us take the value that Knime gives us and fit it right in that little, the square peg round hole that we're working in. And it does it so that we can do it very, very quickly and integrate with all the other platforms that the government likes to use. Because often we're dealing with lots and lots of data. Our architecture is very straightforward. You can see Knime, we're doing ETL, transformation, modeling. A lot of that is with Knime, and often we use it as a GUI on top of Spark, which is also really cool. Allows us to scale the processing in a very elastic way. and then we feed that into really a custom-built UI at this point, built in React and Plotly. So I won't do a live demo. We have a bunch of screenshots for you here while we're up on the screen. Vane is still a prototype. It won't be in production until it passes muster and the government actually makes it what's called a program of record. So what we have now, though, is after we've been in development for just over a year, 12 months, I think, 14 months at this point, yeah? So starting from some initial experimentation that was done in a few different agencies around the algorithm to an actual start date 14 months ago, we've now built out an operational platform that continues to get better, but it's being used by analysts today to see how well it works for them. So the initial screen, we give you the ability to say, log in, and you can bring up any measure. A measure is, think of those as one of our time series, right? So you can look at its historical data, you can see our forecasts out into the future, and users can express scenarios of interest. Like in this case, maybe we're looking at foreign direct investment, right? So that's what you read it here. And the baseline forecast goes off, slow trend down. But they're saying, what would happen if if as the U.S., I'm a decision maker, I can go and make massive investments in Ukraine? What if I go and say, I'm going to do a huge capital investment project. We're going to have a whole bunch of businesses go in and just invest in Ukraine. What would that do to the other measures in this system? And so it gives the users a way to, as a decision maker, hopefully very simply, because they're just clicking and dragging little dots around on that chart, and then saying, run this scenario, and it processes, and it spins off a bunch of Knime workflows in the back. Often as many as 150 workflows at once get spawned off behind the scenes, producing results, and those results then come back looking like this, where now we've said, okay, you've configured some scenario. In this case, it's what happens if there's a Russian economic collapse. And you have everything from, here's the top changes, the biggest changes in the measures that we track. Here's those changes over time. Here's those changes by country. It's all filterable. So if you look here, you can slice and dice by countries, by the measures themselves, by time, and they can have as many scenarios as they want here on the side, where they're piling in decision after decision. They can play all the different options they want and get quantitative feedback about the impact of those, right? So the impact is effectively, we take a baseline forecast where we don't manipulate the future, and then we compare that to another forecast where we've projected pieces of the future out, and we've let the model fill in the rest of the gaps. Does that make sense? We also do the likelihood assessments. So this is where you said, oh, I want to know what's the likelihood that Iran, or this is Russian aggression. So what's the likelihood that in 2021 Russia is going to be more aggressive? There's a measure in our data set right now called assault event counts. And so we want to say, okay, there's a certain number of assault event counts over time. What if that goes above some threshold? What's the likelihood of that, right? And so we actually give you a chart that shows that, every month we're ingesting new data, and as we do that, those models update, and you see the different changes on likelihood over time. You see the drivers in that little sand key diagram on the right. It says, oh, if you're looking at what's driving Russian aggression, well, it looks like it's, a lot of it is influenced by China, Ukraine, and Germany as the biggest country-level influencers. They have measure-level influencers as well. And then the drivers and stuff down below that helps express the insights that we have to the users. And then we also have alerts, which again are a great way to do the indicators and warning. Analyst comes in and says, oh, this is a simple example. What's the likelihood that oil is going to be above 119? So if I'm looking at that, it says oil over $110 a barrel. And it says, oh, well, you know what? 5 years out, we actually expect we expect oil to be more expensive. So you get a little alert ping that comes back, and users can dig into that then by looking at the data underneath those data points. So there's a dashboard, right? Users can go in, they can take the analyses that they really want to track, they put it on a user-based dashboard, and they can track it over time. And there's more that's coming. I can tell you, like we said, we're a year in development. We have a whole another year left. There's a lot more that we're building out in terms of visualizing the error in our models over time, visualizing the data itself, visualizing the drivers in a more dynamic way. But even with what we've achieved so far, we're already getting noticed. We've gotten a couple of innovation awards. We have a number of customers who are leveraging the algorithms that we've developed. I got to tell you, the time series forecasting we're doing it's pretty impressive, right? We have this hierarchical linking model that's doing some incredible stuff. It allows us to really just pour in data and have it auto-cluster into things that we can model around. And we're getting folks like next week, we have, I think it's 8 users from Britain are coming out to learn how to use the system as well. So it's really helping our government work more closely with our partner nations using insights that we can share back and forth. It's not the, oh, that's our secret. We'll just tell you what to do, but we're not going to give you our secret. This gives us a way to actually say, here's the data. Here's why we're making this assessment. Why don't you try it yourself, right? So it's a compelling capability for those reasons as well. With that, I think we're done. Questions?
The handsome guy with the mustache is Jim Frank.
So a lot of the time I start by breaking down a problem into kind of the smallest unit. And so with the countries example, is that kind of a collection of things? Because I would assume that country is an important kind of unit for this type of analysis. Or is that something that tensor completion handles as well?
So
how do you scale your problem?
Yeah. So the way we represent in our tensor, the countries are a dimension in the tensor, right? That's we have like a spatial dimension in the tensor and the coordinates in that dimension are the countries in this case, right? In terms of breaking down the problem, I mean, that we still needed to break it down. I mean, we built this initially around just Eastern Europe. So we had picked a few countries right in Eastern Europe that was very much specific to the. Obviously, we're concerned about this hybrid warfare issue, and the place where we're most concerned about it is NATO, because if there is a NATO incursion, we still will rise up and defend our NATO partners, right? So we want to discourage that from happening. It's a very expensive mistake. So we focused on that region and really broke down the problem by isolating to fewer coordinates to prove out the methodology. And then now we're slowly adding more coordinates to the different dimensions of the tensor, and that is impacting. I'll tell you, most recently we had to solve an impulse response problem in the model because we had too many coordinates in certain dimensions, and the scenario impact analysis was effectively taking the user's input as, here, this is what I want the future to do, and it was saying, that's an anomaly, and it just would wipe it away, right? So we've had to work on solving some of those problems, which have appeared as we scaled to bit more and more data.
Hi. First of all, I think this is really cool. I was looking at the databases that you guys, I think that's a subset of the databases you probably showed up there. What I did notice is some of them are very lagged in a time series. So my question is, like, those aren't missing values, it's just that they are late for the party.
Oh, you're absolutely right.
How do you adjust for that?
Yeah, that's actually why we chose tensor completion, because again, with tensor completion, the imputation allows us to fill in gaps in the tensor wherever they occur. If they're in the future, if they're in the past, if they're right in the middle, they just get filled in. So yes, we have a number, like the Global Terrorism database, right? That's a yearly database. The last release they had was up through 2018, I think, or was it 2017 data?
They're accelerating to quarterly, and their goal is monthly.
I should mention that's another CTTSO funded project. So if you're using that smart global terrorism database, that's these guys to thank. So yes, I mean that is how we solve it. The tensor completion we rely on to deal with all of those sparsity issues. Now, okay, let me take one step back. There's also a temporal disaggregation issue, right? So we take a lot of those sources are instant, like I can tell you exactly when a news article was published, or I can tell you exactly when the weather was a certain measurement. But for migration, we get migration numbers once every 5 years, right? And so if I'm going to now make monthly predictions, which is what I was showing up here, I've got to be able to take that 5-year sample size and disaggregate that down to something that my model can train on, right? So there's other tricks that we use to do that, but I mean, yes, it still all results in us relying on the tensor to stitch it all together for us.
I've got one more question, if that's okay. I was just looking at that chart that you had previously where you had diplomacy off to the extreme right there.
Far right, that's a good thing.
Yeah. So is this affecting diplomacy by any chance, or would it eventually?
Well, we hope it to when it goes into production. That is. So I'll tell you that the actual sponsor of the work is Bill Bush. He is known as the senior foreign intelligence official for the Department of Defense, right? So his job is every day he briefs the Joint Chiefs of Staff. So really he wakes up and he sits down with the Chief of Staff of the Army and he says, here's what I think is going to happen in the world. Here's what I think we need to do about it, right? and then they sit down with the Joint Chiefs, and this is the daily battle rhythm of our senior leaders. This is his tool. His team, he has about 60 analysts, and their job is to fuse all the intelligence from across the IC and bring it together into one little picture that they can brief in an hour to the chief. And so the idea is, well, if we can give them, that's a lot of, right now, they're doing this sort of thing, right? We're trying to give them a dynamic dashboard that not only can they brief from, that gives them these quantitative insights, and heck, the chief himself could dig in and play with it. So yes, we do hope that it will influence. It's not today. Right now we have Bill's team using it, we have some other folks using it, but I would argue that we have told them explicitly it's not ready for prime time. We're still trying to refine the model. I mean, I'll tell you, because we have everything predicting everything, we're good at predicting some things, and we're bad at predicting others. Like stock market. I'll tell you, once this becomes great at predicting the stock market, we will stop being a federal integrator and be a hedge fund. But I need the stock market in the model, because when the stocks go up or down, that affects protests, right? There are we're doing correlative work here, but we know there's causal things we want to try to build into the model. So there's a long way for us to go in this, and we're hoping to get there soon.
So the other little thing to keep in mind when this actually transitions to a program of record, the data sources that are in this now are selected for two reasons. The first criteria is that they are indicative at some level of gray zone activity or nonlinear warfare or hybrid warfare or whatever the new word is for the Russians taking things. But the other criteria is that they're all free.
We're doing this to prove the methodology, right, on the low side. Now, that said, if we go back to that slide at the end of where we're all using it, there are classified, we've already started on the classified deployments. And some of those, again, using our classified sources, you can imagine what those are, making predictions for more specific events that are of direct concern to us, and it's proven to be incredibly successful. We've actually, well, I can't say that. So it's very successful.
Thank you.
Well, thank you very much. Another round of applause, please.